Welcome to the today's LeetCode problem, and the today's LeetCode problem is named as lowest common ancestor of deepest sleep. So this is the problem which is related to the binary tree basically. What we have given, we have just given the root of the binary tree and we have to return the lowest common ancestor of its deepest sleeve. So first of all, there are two terms. First is the lowest common ancestor and second is the deepest sleeve. And this problem is basically a combination of the two sub problem you can consider. This is a separate LeetCode problem. If you have solved, that is the lowest common ancestor of given two nodes, that is P and Q in the tree. We have to find the lowest common ancestor and the deepest sleeve. This is the new kind of the problem that we will see how to solve it. But of course, we will solve this problem in two steps only. So node of a binary tree is a leaf. If and only if it has no children, that is of course if something, this is kind of the tree you have, so these are the leaf node. This is not a leaf node because it has the childrens. The depth of the root of the tree is 0. This will be the 0, this will be the 1 d. Then the depth of each children is a d plus 1. Of course, if this is a d, this will have the d plus 1 depth. Why they have given is this? Because we want to find the deepest leaf, that's why. The lowest common ancestor of set S of nodes is a node A with the largest depth, such that every node in S is a subtree of root A. What does it means? For example, if you have a tree like this, correct, and if I am supposed to find the lowest common ancestor for this node and this node, so if you see, the lowest common ancestor would be this node only. Why? Because from here only I can reach here, from here only I can reach here. There is no common intermediary parents for both nodes because both belongs to the separate subtree basically. And for example, if there would have been something, the tree would have been something like this again, okay, so still this would be the deepest common ancestor. Why? Because we have to find the lowest common ancestor of a deepest leaf. So these are my deepest leaf, correct, these all four, and these all four have the lowest common ancestor, this node only. This is what we have to find, correct. So let's understand this with a simple test case given here. This is something that we have given. First of all, first question is a find deepest leaf. This is our first question. And second, find their LCA, lowest common ancestor. What are the deepest leaf here? So deepest leaf are this one, 7, 4, correct. Why? Because why 6, 0, 8 are not there? Still they don't have any child, right? This doesn't have any child, this doesn't have any child. So these are also the leaf node, but we are more concerned about only the deepest leaf, not a leaf. We are concerned about only the deepest leaf. So these are the deepest leaf, 7 and 4. And okay, now I got the deepest leaf, not leaf, sorry, leaf, 7, 4, correct. Now I have to find the LCA for this 7, 4. So if you know the standard algorithm for finding the lowest common ancestor, you can find this using DFS or BFS. Same for deepest leaf also, you can use the DFS or BFS. Any tree problem can be solved only using this simple two algorithm, DFS or BFS. So LCA for 7, 4 is a 2 only, okay. So that's why the output for this test case is a 2 only. Even though you can see here the 2, 7, 4, it's not an array 2, 7, 4, 4. It just we have to just return a node of the lowest common ancestor, that is a 2. So if you are returning this, ultimately this tree subtree will be written as output. That's why in output we can see 2, 7, 4. But we have to return just only this node, that is a tree node of 2. That's it. This is what we have to return in this test case. Now let's see how we can solve this problem. First of all, there are two. This is a two-step solution, right? First, let's find the deepest leaf, and then we have to find the LCA. So we will now, let's first discuss about the how to find deepest leaf. So see, in order to find deepest leaf, you can use either BFS or DFS. Both works, right? Any of the works. The simplest would be the BFS. Intuition will be simple. How BFS work we know, right? It works level wise. For example, given the tree like this, for example, given a tree like this, you know, right, this is a level 1, this is a L2, right, this is a L3 and this is a L4. and deepest leaf would be the L4. Last level nodes, whatever the nodes are present at the last level are the deepest leaf. Simple, right? So what we will do, if we are in BFS, we know that we use a queue data structure. In the queue, initially we put a root node. Root node is this one, correct? Then we process all the nodes at that level. So for root node, I will process in queue. This is my something, right? I will pop it. I will put all the childs of the root node, that is this and this. So I will put them, correct? For this one, let's call this as x1 and this is x2. So this is my x1, this is my x2, correct? So again I will process all this, and for example, if I have any list or any variable called as a deepest leaf, this is my list only, which will consider the leaves. So I will just assign it to this. So my deepest leaf will now become x1 comma x2, correct? Let's call this as a x3, x4, x5, x6, x7 and x8, correct? I'm done now. Now in my queue there are two nodes, x1 and x2. I will process them, and you know how to process using for loop only for the size of queue. So I will, if I process, I will ask x1 and x2, does it have the left and right node? So if you see, for x1, x3 and x4 are the childs. So I will just insert them into the queue. So x2 will be there, x3 will be there, x4 will be there, comma x4. And as we are running for size, so we will run 2 times only. So again I will remove the x2 and I will just put now as it is. What are the childs of x2 and x, that is x5, x6. So I will just put them, right? And I will, every step, once I am done with looping, then I will assign the deepest leaf to this one, whatever I have got, that is x3, x4, x5, x6. Makes sense? Now I have this queue. I will run my loop now for 4 times, correct? Because there are 4 elements. So I will ask x3, do you have any childs? So if you see, x3 has x7 and x8. So I will remove it out. I will just say now x4, x5, x6, x7, x8. As I am running 4 times, 1 is done. Now 3 times. So I will remove this. I will ask x4, does it have? No, it doesn't have. Then I will remove x5, does it have? No, it doesn't have. I will remove x6, does it have? No, it doesn't have the childs. Now ultimately I am remaining with this thing. So deepest leaf will be now assigned to the x7, x8, correct? So if you see, ultimately using the BFS I am getting the deepest leaf at last, because I am traversing level wise. So last level nodes will be the deepest leaf. Same with DFS also you can do. What you can do for DFS only, let me take the another tree here. Okay, for example, this is my deepest leaf. This, so how will I do using DFS? You know, right? Using DFS we first go in depth to the left, from left to the right. So I can maintain the one variable, that is a max depth, and of course the deepest leaf. Again, this will be the list and this will be the integer. Initially it will be 0. So I am starting from here. I will just say, if I have one function which is taking depth, which is taking max depth, and which is this list, basically at every step I will see depth. First of all I will check what is the depth. Depth is 1 now. Is it greater than max depth? Yeah. So I got a new depth, so I will assign max depth equal 1, and whatever the root I have got, I will put it into my deepest leaf. Then I will, from here to here, I will go here and here. Now I will increase my depth plus 1. So now my depth is become 2. Again I got the new depth, so I will assign it, and I will just remove this list, and I will put whatever the nodes I am getting at depth equal to 2. Same from here to here I will go. Now my depth will become 3, right? And whatever the nodes I am getting at depth, I will update my max depth to 3 now. Whatever the nodes I am getting at depth equal to 3, I will put it into the deepest leaf, and so on I will do, and ultimately I will get the nodes. I am not going in a depth because this is something that is very simple using the DFS or BFS, but I have explained you already the solution using BFS, and that's what I will explain you via code as well. I will explain you the code of DFS as well, but still I want to focus on only one of the approach, so I will focus on the BFS only, right? So pseudocode for BFS is something nothing but we have the queue, correct? in which initially we used to put the root node, correct. Then we use something like this, while q until I have the q size, correct. Then we take a level size. Level size is nothing but a length of q, whatever the q has, number of elements. Then we run a for loop for this in range, correct, some for loop for level size. Then we do q dot pop left, basically removing the element, right. And then what we do, we just say if this will return with a node, correct, node. I am just checking if my node has left. If it has, then I will just say q dot append. I will add that node into my queue now, because I have got the left child. Same for right. If I have the right child, that is node dot right. If I do have the right child, then I will just say q dot append node dot right. So I have got this, and after I am done with this for loop. At every step, this node I will be putting into my deepest leaf, that is a deepest leaf dot append. This is my dictionary. I will just say node, and this will contain all level wise node. And at every step I will just say final. If I am having any variable, for example final deepest leaf will be nothing but this deepest leaf, whatever I have gone, and it will ultimately replace the previous one values, because we got the new level wise values. And of course at last I will just return this one, return final deepest leaf. So now final deepest leaf is a dictionary or is an array which contains all the nodes present at the deepest level, correct. Now I have got this, okay. If this is my tree, correct, this is my tree. So in my deepest lift I will have these 4 nodes, correct. Now I have to find the longest common ancestor for these 4 nodes, correct. For example, if this is my x1, this is my x2, x3, x4, I have to find the longest common ancestor. But let's have some observation here. If you see, do you really need to find longest common ancestor for all nodes? What if I say just let's find for x1 comma x4, find the lowest common ancestor for x1 comma x4. Why I am saying is because see, these are nothing but redundant nodes, correct. So ultimately if you want to find for all 4 nodes, you have to just run the for loop in for all nodes in big of n square, because you have to make a pair of x1 comma x2, then x1 comma x3, then x1 comma x4, then x2 comma x3, right. And you have to return the common of it, basically the common result, correct. And that will be of course big of n square solution, which we don't want to do. So best observation is here that just find the lowest common ancestor for leftmost and rightmost node. Ultimately that will include the lowest common ancestor for the between nodes. Why I am saying it, because see, what is the lowest common ancestor for x3 and x4? This one. What for x1 and x2? This one. What is the lowest common ancestor for x2 and x3? This one. What is the lowest common ancestor for x1 and x3? This one. For x1 and x4? This one. x2 and x4? This one. x3 and x4? This one. But this is not a solution, right? This is a solution, because this is a common for all. And if you see, what is the lowest common ancestor for x1 and x4? So if you see, ultimately this is a path, this is a path, they are reaching here, so this is the solution. So we don't have to consider all in between cases. If you find the lowest common ancestor for leftmost and rightmost node in the deepest leaf array, you are done. You are done with it. So if you see the deepest diff, this final deepest diff, ultimately consider all the nodes in order only from left to right. So it means just take the first 0th index element and last index element, that is a -1. Find the lowest common ancestor for these both, LC of these both, and return that as an answer, and you are done with the problem, correct. Now how to find the lowest common ancestor, that is a second question now. So given a tree like this, if I want to find the lowest common ancestor for x1 x2. What is our approach over here? What is our approach? So if you know, lowest common ancestor function looks something like this. LCA of root p and q. For example, this is my p, I am considering as p, and this is my q, and I have to find the lowest common ancestor for it. So at every step, the pseudocode for lowest common ancestor is that you are starting from here. You are just checking whether both nodes are in left side. Yeah, it is. Then you go to the left only. Again you check for this node whether both nodes are left or right. Right, you go to this side. Now at every step you check whether you are getting both nodes from left and right. Yeah, it means root is a lowest common ancestor for it. So there are three checks basically. If getting from left and right, then LCA is a root. If getting from left only, LCA is a left child, whatever the left child it is, and same for right. If getting from right, then the LCA is the right child only. So if you see here, this is my P and Q. Okay, this was my P, this was my Q. I am starting from here now. I will just check whether, first of all, my case would be, I will just check, hey root, can you just tell me from which side you are getting it, where the P and Q are present basically. So it will say me no, it is present on left side. So I will just go to the left side. I will ask again this root, hey root, can you tell me on which side the both P and Q are present. It will tell me on left side, on right side. So I will just go here. I will ask this root, hey tell me on which side it is present. It will tell me, hey both roots, both the P and Q are present on right as well as the left. So this case and this case means LCA, right? So I will just say, okay, return the root in this case. So this is the pseudocode for LCA for finding it. What do you do? First of all, you just check if root is not equal to null. If it is not, if root is equal to null, then there is no LCA for it. So you can just say return none. Correct? Makes sense. I will check if my root is equal to P or root is equal to Q, then I would just say return root. Why I'm this saying is, for example, there is a case given a tree x1, x2, x3, and you have to find the longest common ancestor for x1, x3. Means these nodes. What is the lowest common ancestor? X1 only, right? That's why root will be x1, P will be x1, Q will be x3. So if you see, if my root, this one is equal to P or equal to Q, I just have to return a root. So that is the case over here. Correct? If this is not a case, then I will just find the left with whatever the function I have. I will just say root dot left, and I will just pass P and Q as it is. Same with right. I will just say function of root dot right and P and Q. And again, now I will ask my root, hey, are both present left and right? If both are present, then I will just say return root, because now I am getting both things from both sides, left and right. So root is my LCA. If only right is giving me, it means my LCA is a right. So I will just say return right. And this is something happening recursive due to this case, function. If left only, means only left is giving me, only this side, it means just return a left, because left is having both childs or both nodes basically. Or at last I will just say return none, because there is no LCA present for given P and Q. So this is a pseudocode for LCA to find it. Correct? So this was pretty big, I would say. So the approach, okay, I will just go through the approach only. What is our approach? Find deepest lift, find the deepest lift, correct, using BFS. And second, find LCA of deepest lift first, that is leftmost, and last element. Last element means node, basically node, that is extreme right. So if this is my tree like this, I'm just finding LCA for this one and this one. I'm not finding for this one, because even though they are deepest leaf, but I will find this one, because ultimately this will give me the answer for all nodes. So code for this problem is simple, I would say. So this was the main function, okay, given to us, and I have written the steps over here as well. So what I have done, I have built the solution using both, that is a DFS as well as the BFS. I will explain you only the BFS solution here. I am not going for DFS. So what I am doing, self.bfs is my function. I am passing the root. It is giving me the deepest leaf. So let's go for BFS solution. This is my BFS. I told you, right, I have to return a list at last. So this is the deepest leaf. That will be my final answer. I am taking the queue. Into the queue I am putting the roots. I am taking the current level nodes as a list and level size. And as I said, we will run a for loop for the level size. I am taking out the node from the queue, okay, and then I am just appending into the current level nodes. This is my current level nodes, because current level nodes I will replace with the, basically at every step after every level I will just say deepest leaves equal to the current level nodes, and that is what I am doing here. And at normal or standard BFS for level wise, if there is a left node, append it into the queue. If there is a right node, append into the queue. And ultimately I will return the deepest left. That's it. Correct? Makes sense? Then what I'm doing, deepest left of extreme left means 0th node, and last node is the extreme right. This is the leftmost leaf, rightmost leaf, and I'm finding the lowest common ancestor for leftmost leaf, rightmost leaf using the root. And the function is simple. This is the standard lowest common ancestor problem. You can go and watch on YouTube other videos. What I'm doing, if root is none, then return a null. If root is equal to P or Q, just return a root. Because this is the case, right? We already discussed. This is my x1, this is my x3, this is my x2. If given P equal to x1, it means it is a root only. So I will return a root only. Then what I'm doing, I'm finding to the left side, finding to the right side. And if I'm getting both, if I'm getting P on the left and if I'm getting Q on the right, it means I will return a root, because this might be the case, x1, x2, x3, given P equal to x2, Q equal to x3. So on right left I'm getting P, on right I'm getting Q, so I will return a root, because root is the answer for this solution. If I'm getting both things on the right, I will return the right. If I'm getting both things on the left, I will return a left. Otherwise I will return a null. And ultimately this will give me the lowest common ancestor for this, and this is what we have to solve. So time complexity for this problem is big of n. Why I'm saying is, so BFS will take big of n only, because it will reach to the all nodes at once only, exactly once, and similarly for lowest common ancestor it will be the big of n. Space would be in this case big of n in worst case scenario, if it is a skew tree, or it will be the big of h, okay, if it is a balanced tree. And yeah, so this is how you can solve this problem. I hope you got it. The code I have put in the description, go and look at it. See you in the next video. Thank you.